afternoon, and welcome to our webinar today on the benefits of 3D printing for your business. I'm Russ Bahnam, your host for today. It is now 31 years since Charles Hull invented stereolithography, a printing process enabling a tangible 3D object to be created from digital data. But it is only recently that we've seen such extraordinary improvements and far greater use of 3D printing technology. From the early days of manufacturing simple plastic shapes, today's 3D printers can now build a range of highly complex components at remarkable precision, speed, and low cost. Products are made from an ever-widening array of additive manufacturing materials, such as clear, rubber-like, and biocompatible photopolymers, or tough, high-performance thermoplastics. Small wonder that 3D printing has become the new paradigm of design and manufacturing, a technological disruptor transforming the competitive landscape in diverse industries. Indeed, with 3D printing at the front lines when it comes to the future of business technology, today's webinar could not be timelier. With me today are 3D printing experts Bruce Brashaw and Kevin Dowling. Bruce is Vice President of Marketing North America at Stratasys, the world's premier manufacturer of 3D printers and production systems. Kevin is Vice President of Engineering at 4Moms, a maker of innovative baby products that is using 3D printers to turn creative ideas into manufactured prototypes in a single day's time. As you listen to both Bruce and Kevin, please use your computers to send questions to either gentleman using the Ask Questions button on your screen. We will address your questions near the end of this webinar. So, let's turn now to our panelists for their views and thoughts. Bruce, as I mentioned, 3D printing has moved to the forefront of discussion in many industries today. As is always the case with a game changer, there's some confusion regarding what a new concept offers and why it may make sense to relinquish older ways of doing things. So I'm hoping you could shed some light on what 3D printing is and what it offers. Tell us a little bit about its evolution and its promise. Bruce?
Russ, thanks very much. I appreciate that. Again, my name is Bruce Bradshaw. I'm Vice President of Marketing for Stratasys here in North America. Let me go through a little bit of some level setting for folks. There's lots of noise about 3D printing in the industry, and it's known by many different terms. And on the screen here, you'll see 3D printing, rapid prototyping, rapid tooling, additive manufacturing. There's lots of terms. So as we go through this presentation, the term 3D printing kind of encompasses all of this. So just to level set folks a little bit. Again, as you see, the terminology for additive manufacturing, again, it's covering all the terms. It's a replacement for RP. That's kind of the early on nomenclature for it, or additive fabrication. And again, it's a collection of technologies driven by CAD data, whether that's from a software package like SolidWorks or Creo from PTC or Siemens. Can also be a CAD model in the medical market from an MRI or a CT scan. So it encompasses all that fun stuff. It really is the next industrial revolution. I think The Economist had it in its publication, or labeled it that, a couple of years ago. And it's really helping designers perfect their ideas. So from the napkin sketch all the way to holding a part in your hand that looks and feels like the real end-use product that's been manufactured. It's actually helping manufacturers in two ways, and I'll get a little bit more into that, but it's not only helping them manufacture end-use products, but also helping them with the manufacturing line, and I'll touch on that a little bit more. And again, it's helping individuals, engineering teams, companies, colleges, all kinds of groups working together to bring products to market. It's funny, 3D printing has been around. Russ mentioned Chuck Hall inventing it in 1984, and our founder, Scott Crump, inventing FDM in 1988. But people don't realize it has been impacting us for many years in lots of ways. From the time you wake up in the morning when you hit your alarm clock radio to the time you go out into your kitchen, all your appliances, your cell phone that you use, your tablet that you use, your baby products like Graco baby products, or your level or blinds, or your interior car parts. All of them have been designed with 3D printers, and it's been that way for years. And now there's lots of companies, like even software companies like Yahoo and Google, jumping into the fray. But it's been impacting us quite a bit, and we just don't realize it. The move to manufacturing, I think, is going to make it more real for folks, and I think the exposure of 3D printing because of the consumer level printers has brought it more to the forefront, but it's been impacting us for a long, long time. If we talk about the impact of 3D printing on the economy in itself, there's lots of stories and lots of articles written about this, but you're starting to see research firms like McKinsey and Gartner and Waller's all starting to look at the industry, and it's pretty funny, they're all within the same range. It's estimated that it'll impact the economy somewhere between $230 billion to $550 billion by the year 2025. And manufacturing will obviously, with implants and tools and things along those lines, at about $300 billion. Transportation, I won't go through all these numbers, but you can see how 3D printing is impacting the economy. Within 10 or 15 years from now, it's going to have a huge impact. And I referenced it in the previous slide. We're impacted by it now. We don't realize it, and I think as days and years move forward, we'll see it more and more. It's interesting, the timing of this slide. This slide we've had in our slide deck for a couple of years now. This was 2 years ago. President Obama talked about 3D printing and how it's going to revive American manufacturing. The timing of this from the State of the Union a couple of days ago is interesting. But, it's a technology now that's at the highest levels of government, in terms of funding, in terms of education, in terms of focusing on bringing manufacturing back to America. So things like grants for students, regulations for intellectual property, things along those lines, it's starting to impact. So it's an interesting look at it as well, that it's not just in the private sector. The public sector is looking at 3D printing as an important technology as well. 3D printing, as I mentioned, has been around for many, many years, and I like to say that it's not a mature technology in the prototyping side, but I think it's an understood technology on the design side of stuff. For many, many years, folks have been using 3D printing to design their widgets, to design their medical devices, to design their automotive car parts, as I talked about before. And they've been using it in these phases, as you can see. Obviously, the idea of it, as materials have advanced, they've been using it for design validation and functional testing. And then, as I referenced before, we're now starting to see it on production setup. The same time BMW's designing their next car, they're designing their next manufacturing floor, and they're using 3D printers for tooling and jigs and fixtures to help with that design. So at the same time they're bringing the product to market, they're designing their manufacturing floor. And then, obviously, the holy grail is a short-run production. There's something on the order of 200 parts flying on Boeing aircraft that are printed on 3D printers today. So we'll talk a little bit more about that as we get into this. In terms of the industries that it's touching, I put this slide up because I think everybody participating in this webinar can assimilate themselves to one of these industries. It's impacting everything from the aerospace, as I referenced, all the way to dental. You remember going to your dentist and then putting the goop in your mouth for your impressions. That technology is now going away. They're actually going to scan your teeth and send your impressions either to a lab to print out the impressions, or they'll have a 3D printer right in the office of a dentist or an orthodontist. So it's changing many, many industries overnight. So this is just Russ, a quick high level of 3D printing today. With that, I'll kick it back to you, and I'll jump back in again a little bit more later on the presentation. Thanks.
Well, thanks so much, Bruce, for your insightful comments there. As always, the most tangible expression of a product's value is in its use by a company. Let's turn now to Kevin Dowling for his company's journey toward using 3D printing in the manufacture of its products. Kevin, tell us a bit about 4Moms and especially its evaluation of the benefits of 3D printing and how 3D printing has impacted 4Moms from a manufacturing and a business standpoint. Kevin? Welcome.
Great. Thank you, Russ. Thank you very much, and Bruce also for that background on 3D printing as well. Bruce's excitement around 3D printing is palpable here at 4Moms. 4Moms is a relatively small company. We're doing around $50 million a year, but we're growing very fast, and our products are baby products that are innovative and new to the market, and we're sold all over the world, and we need to do things quickly. Our time to market is probably one of the most important things that we do in terms of getting products out and making sure that we're doing that on time. If you look at the variety of products that we do, we make the world's first power folding strollers, innovative play yards that are very easy to use, and rocking systems that move babies like mothers rock their babies. Very innovative ways of doing things that have been around for a while. In order to create these products, we need to do quite a bit with prototyping and design. There's a huge emphasis on design at 4Moms. And within the company, our engineering team and our design team and our supply chain teams work collaboratively, very closely together. They're co-located. And this part of the development process in our environment lends itself extremely well to using 3D printing to realize concepts, changes, and new designs in at a very, very fast pace. So 3D printing is really integral to our process and allows us to do new prototypes, in some cases overnight, because 3D printing allows us to do that. So we're able to improve and change products on a daily basis within the development phase. If you look back at the timeline that Bruce showed earlier, we do everything up into the production short runs, but prior to that, we use 3D printing throughout. Many of the things that we do use 3D printers are to accelerate product development. And fortunately, with 3D parts, the structures and the materials today are far ahead of where they were a decade ago or 2 decades ago. I had the opportunity in school to use some of the very first 3D printers, and they were not nearly as advanced as they are today, both in terms of speed and materials and so forth. And the machines we're using today allow us to do things that get us as close as possible to the end product without actually having the end product. And that's very important for reviews, for us to understand the geometries, fits, and so forth. And it's good enough that we can also integrate other parts that are perhaps not needed to be replicated on a 3D printer. These might include metal extrusions, which we can do relatively quickly. In a few weeks, we can have a die, make extrusions, and incorporate them directly into products. Of course, that's not nearly as fast as a 3D printer, but sometimes for certain prototype cycles, it's good to have the real and final parts in there. Additionally, we can integrate motors and sensors and make actual working devices. Oops, I don't know why that suddenly changed. And as a result of integrating those into, let me move to the right slide here, as a result of moving electrical subassemblies, perhaps gear trains, which are not well suited for RP parts, metal fittings, even fasteners, we can actually create working systems directly using 3D printed materials. That allows us to do fit checks. It allows us to assess the aesthetics of a design where you sometimes just can't capture it in a rendering. We can also evaluate any changes that we do from the aesthetic or functional side very, very quickly. And sometimes we do prototype cycles on a weekly basis just to improve or change that. And without 3D printing, it would be extremely difficult, if not impossible, to be able to do that. For the purposes of communication of the product status, as opposed to showing drawings or renderings on a computer or 3D CAD, which serves a great purpose, for marketing and ID and even user guidance, where we bring devices to customers to get their feedback. There's nothing like having a full 3D printed device to be able to do that. We also find in that rapid development phase that errors and other issues are found fairly early in the product development process. Without that, there's no doubt that some issues and challenges would make their way toward production, where it gets more and more expensive to fix and change the later you get in the process. We also internally here at 4Moms use 3D prints as molds. Basically, the idea is that we can do pour of urethanes and other thermoplastic materials into a 3D printed mold of the device. So we're, as opposed to designing the actual parts, we're designing the negative of that, the mold, and we can create an actual molded part. And that might be a very soft material or one with very specific material properties that we're not able to easily replicate in the 3D printed materials. However, I would say that one of the great changes, and I was recently at CES a few weeks ago, is the enormous range of materials that are now available. I've seen carbon reinforced materials and other things that are really improving the capabilities of these devices. And even going to 3D printers to design and print those molds and then turning those around, usually within 24 hours we can actually mold some of these very soft parts very easily. The other is that the electronics within the devices, if we want to test out sensors and configurations, one of the great challenges in making any product that incorporates electronics and processing and sensing and actuation, essentially think of robotic devices, where we're now integrating that into a wide variety of products collectively, I'm not just talking about 4Moms, is very often in the process, it's very difficult for that team, the software team, embedded software, and electronics and sensing, to be able to start real testing. And we can now do that usually within a couple of months of starting a project. We'll have some designs, some candidate designs. We can breadboard electronic systems and software. But being able to test an actual system with the actuators, with the sensors, with the actual code comes much, much earlier in the project, as opposed to being pushed out to late in the design process. And very typically, at least in my experience, that part of the development gets squeezed tight, and you end up spending many, many long hours in order to get things done. So all of these things help accelerate product development. If we look at 4Moms in terms of our own capabilities internally, we have currently actually a good collection of a half a dozen or so 3D printers. We invested early on in the smaller U-print devices. We found that that helped a great deal. We invested in another U-print device. We then purchased a larger Fortis, and the main reason for that was the capability of going to much larger volumes. When you're working on a car seat, for example, the U-prints would have to make multiple sections, which are then glued or fastened together in some way. In the Fortis, for many parts, we can do full scale, or at most have to do two pieces in order to attach them together to form a full-size part. In addition, one of the object pieces also made by Stratasys allows us to do clear and translucent, gives us better resolution for some parts as well. And so this stable of printers is serving us very well. We're looking certainly to augment this in the future because we are using these machines quite a bit. And in fact, that leads me to one of the challenges we've had, although this, for a relatively small company, this is a nice set of printers, but one of the challenges is that we can make these design changes. We can do immediate evaluation and feedback, I'm showing here. One of the great things, before I get to the challenge, is that we have fewer issues with the final manufacturing. In other words, we know the product well. We can get the final CAD out, final drawings with specs, geometries, tolerances, and so forth out to the manufacturer, and we end up with far fewer issues in that phase because of 3D printing. And that's made a remarkable difference in our time to market. Our products are not just one type of material. We have injection molded parts, aluminum extrusions, fasteners. Also probably unique for many manufacturers, we have soft goods as well, which are fabrics, textiles, and a variety of other materials that are used in it. But rapid feedback is necessary at each and all of those stages. The one thing we found, though, is that the printers have become so popular that our utilization rate is typically above 80%, and often, I'll give a few examples over the past year, we've hit 95 to 98% utilization rate. And what that means is that those printers are busy 98% of the time, 24/7, evenings, weekends, every day. And what that means is that scheduling has actually become an issue. It's become a scarce resource to some extent. Now, of course, an easy way out would be to buy more printers, but that gets into even more expense. But we found that through some smart scheduling, having Outlook, we started with some very simple ways to do it. But these types of tools for scheduling are very important, and being able to remotely monitor these tools is also very important. The machines need care and feeding. They're not just going to operate perfectly by themselves. They're not quite the stage that a printer, a traditional laser or inkjet printer is, because they do need to be cared for. There's a lot of moving parts, literally, and some care has to be taken in making sure that those machines continue to operate. So what part of what that's meant as an impact to the organization is that the high utilization rate and having a pretty good size stable of machines means that we're running through a lot of material every month. We're doing tip changes. We're changing out the type of materials. And so the maintenance, including PM, means that we have to have someone who spends a lot of time. And we had engineers doing that for quite a while. If you want to do tip changeovers between jobs, material changeover, we also have engineers doing this. But what it meant was that over time we realized we really needed a full-time resource to work on the printers, make sure they were operating, work with Stratasys when there were challenges or issues that had come up over time. But the machines are kept so busy, there's no doubt at some point you'll have to do some maintenance or fix something. But what we found was that 6 printers, we really needed most of a full-time person to maintain these devices, and a dedicated resource made a lot of sense. It improved the uptimes in the system, increased our utilization rate, and ensures the machines are ready at all times. So that was a big thing. We now have a very, very knowledgeable person so that in-house we can get a lot of things done and fixed very quickly. So there were some aspects of 3D printers where we sometimes don't use them. We currently don't use them for manufacturing. I know that will happen in the future, so we consistently keep an eye out for that. We're not in the medical device industry. We're not in the aviation industry. So the types of economics and the scale and numbers of parts are very different for us. We're doing high volume parts, which are tens to hundreds of thousands of units a year, and it's just not possible to hit the cycle times that are necessary, typically 30 seconds or less. Even extrusions and so forth are relatively cheap and quick, and we can turn those around quickly. Another area is final part strength, where crash tests, as you might imagine. There are batteries of tests that are required for car seats, and even strollers and rockers have quite a few tests. The final strength of the part is typically not what is required, but it's close. I would give a rough guide around 60%, and having machine or even molded parts are more suitable for those particular tests. But for the purposes of getting something to be functional and show it and test it, there's a lot you can do with the 3D part. But if you have to meet certain strength criteria, the printed material, let's say a nylon, for example, you'll probably reach around 60% of the cost. You'll sometimes see parts split along the build layers within the device. Nonetheless, it's still an incredibly and invaluable part of our product development process. I would say if you look at our wish list, it's pretty typical. I think most people who have 3D printers always wish for more, and we're no different in that respect. We'd love the finish to be better. We'd love the print times to be faster, and even the operating costs we'd love to be lower with the various materials and other things. That's happening. There's no doubt that as the volume of printers continues to grow, as the competition in that space, many of these companies, Stratasys of course included, are delivering better and better products every year. It's really like almost watching the computer industry in the early days. It's just amazing. I mentioned some of these materials. I talked about the strength issues in the final molded parts. You can't always depend on that. That's not always the case. We've done quite a bit of mechanical testing of systems in order to see how far and how close we are to the final strength of a molded product. The strain characteristics that you see, and here you see a finite element analysis of an old piece that we had, they're really a function of how the pieces build, the mechanism, geometry, and more, and we do quite a bit with FEA. So even as we test and look at the final fits, we also examine the strength of the parts and analyze that. FEA really does help us, and of course you need it for many of these types of applications. It's a great guideline, but the part itself, one thing that can help is if you know the high strain areas and you know when it fails and where it fails, that can provide guidance on strengthening certain areas, even if it isn't the same as the eventual molded part. And there are other areas in 3D printing, such as SLA, which is a different type, and then FDM, that are closer to some of the molded plastics that we use in sintered metal systems, which we don't have in-house, is also near equivalent to the actual metal parts as well. So all of these technologies continue to grow and improve, and we'll continue to take advantage of that as the capabilities grow over the years. So I think I'm going to turn it back over to Bruce for some customer examples that he has, which look really exciting.
Yeah, thanks, Kevin, so much for your your informative and frank comments there. And yeah, indeed, Stratasys has many other great customer case studies that Bruce is going to present for us. Bruce, would you kindly tell them about them and assist their questions regarding whether or not 3D printing is right for their business at this time? I also want to remind the audience that this is a highly opportune time to continue asking questions of two individuals who are extremely knowledgeable, as you can tell, on this subject of 3D printing. Anyway, Bruce, please, some of those other case studies.
Great, Russ. Thanks very much. So I'm just going to touch briefly on a couple of other customers that we have.
Yep.
One of them is Fender Guitars. Folks are familiar with it. It's a household name. Sean Green from Fender spoke at SolidWorks for us last year, and here's what he presented to the audience in ways that they use it. So I'll go through this just real quick for you. I mean, obviously they're using it in much like Kevin is using it, where they're using it obviously for prototyping and tooling, marketing presentations, but they are actually using it, again, for guitars and some end-use parts in certain instances. So let me just take you through a little bit of Sean's comments. Again, this is what he did at SolidWorks. These were his comments. He thought it was Connex, by the way, is one of the systems that Stratasys sells. They use it, and it's critical in their design process. These are Fender's numbers, not ours, obviously, but speeds up time to market for them by an average of 40%, which I think is huge. And by the way, this is I would love to say that this is just a function of Stratasys products, but it's not. This is a function of using 3D printing. So as much as they're a customer of ours, I think this is true across 3D printing in general. Saves them lots of money in tooling and in manufacturing time. I know Kevin referenced what they're doing. We do sell a product that allows you to actually do short-run injection molding off of a 3D printed mold. Some people are using that to get to market faster, but I think the larger number of customers that we have are actually using it for tool design, where they're actually making the mold, testing out the tool, making sure it's producing the right finished product in an injection molding machine before they send their tool off to China to spend $50,000, $100,000, $200,000 for their final tool. So it's a neat little added tool for them. Again, gets the part in the hands of other parts of the organization. Allows them to test different styles and designs with minimal cost. Again, I think Kevin referenced this as well, being able to catch some design problems early on before you actually commit to tools and whatnot. The expense in prototyping, it's funny, people think that if you own your own 3D printer, you're going to use it more and your expenses are going to go up, but for them it's dropped by over 50%. They use it, they do lots of post-processing. Again, the parts that I showed earlier on were 3D printed parts that Sean actually produced that were pretty cool that looked like the actual end part. It takes a lot of guesswork out. I think this is his last comment. This one's mine, don't touch it. As Kevin pointed out, there's lots of folks vying for time using these 3D printers, and it's a valuable asset now to Fender. So, for the folks that are on the webinar right now, is it time to buy? Everyone's asking themselves that. The technology's moving so fast. If I buy now, what's going to happen? We get parts for design. I don't see it in manufacturing. Should I? Can I justify the expense? By the way, I apologize for the formatting on these slides. I'm not sure what actually happened, but if I buy one technology, it's going to change, and I need material from another one, and that doesn't work with my machine. What do? Technology is changing so rapidly. If I buy one today, is it outdated tomorrow? What's your excuse? Kevin referenced they started out with about a $20,000 to $30,000 product from Stratasys as their initial investment, and they own 6 machines. And their most expensive machine is probably a $250,000 or $300,000 machine. So they saw the value real quick. The same is true for Fender and a bunch of other customers. Again, you've heard it from Kevin. You saw it with Fender. Reducing lead times and the cost of buying parts if you're outsourcing. You increase the number of prototype iterations. We always say prototype early and prototype often. If you outsource, oftentimes you'll get it back. You'll do your first part 2 months into the design cycle, and we'll hear folks say, if I had this prototype in my hand a month ago, I would have changed my design. Again, it significantly reduces time to market. And the question always is, are these things measurable? And how do I convince my boss they sound good? Stratasys puts this up on their slides, and their customers talk about it, but how do I convince my boss? Sorry for the toggling between. Again, there's lots of noise about 3D printing. What's acceptable in my business? It really depends on who you are. If you're a high school in the education market, your needs are different than a research institute. If you're a Fortune 500 organization, is there standardization needed? If I'm a small or medium business, what can I afford? What's my budget? And I have to make trade-offs between functionality and look of the parts that I'm going to get off and material availability, things along those lines. So they're all things to ponder. Current entry-level machines have the trade-offs between suitable accuracy, mechanical properties, and you'll need to weigh, are those good enough for your environment and what you want to do? But every technology requires post-processing. What's the best for your company if you have resources in place, if you have people in place? All those questions you guys you'll need to think about. How do I integrate it into my processes? You know what I mean? There's lots of best practices on equipment and applications. Interdepartment education, again, I think Kevin referenced it as well. These guys, it's been a learning process for them. However, once you own a 3D printer, the value of a 3D printed part becomes real obvious. We see lots of our customers now who buy it for the design side of stuff, and someone on the manufacturing floor runs in and says, this part just broke. What's the likelihood you can print this thing on a 3D printer? And before you know it, they're doing more stuff on the manufacturing floor than they are on the design side, and the manufacturing floor has to go out and buy a printer. The inverse is true. Once you own a 3D printer, you'll actually start to outsource when it makes sense. The 3D printer I have has got a size limitation or a material limitation, but I know the value of that 3D printed part. I'll go and I'll outsource to one of my service bureau to get additional parts because you understand the value of that 3D printed part. I love doing this in my presentation. There are those that make things happen. There are those that watch things happen. And there are those that say, what the heck happened? You don't want to be the last guy. You never want to be the last guy. I can only encourage you that 3D printers are having a real impact today. Companies are getting value from it. Don't be the last guy. The technology is going to change. The materials are going to change. Efficiencies are going to change. Processes are going to change. But you need to get in now, because if you don't, you're missing out a little bit. So looking on the horizon, as I said before, it's affecting us today, and you don't realize it. The business scalability and vertical applications that aren't here today are coming. Kevin asked for it in his slides. I want to be able to produce different components, different requirements. And the technology is changing, and it's going to meet. If it doesn't meet your needs today, it will very quickly. And it's grown from a niche market to mainstream. And again, it's gone from a nice-to-have to a must-have. You need it as a competitive advantage to stay ahead of your customers, to stay ahead of your competition, and to meet customer demands. With this, I encourage everybody to reach across your desk and grab a tissue. I'm going to have a video played for you to again, another human element of how 3D printing is impacting some folks. So if you could play that video for us, it would be great.
When she was born, her legs were up by her ears and her shoulders were internally rotated, and she had ulnar deviation on her hands and rocker bottom feet. A geneticist came upstairs and told us she had arthrogryposis multiplex congenita. They brought her legs down and they casted her, and slowly and surely she started to develop. Our first year with Emma, we found out that there was going to be a conference, and it was in Philadelphia.
It was an arthrogryposis family meeting in Philadelphia where I described the Rex.
We watched a presentation on the Rex.
And that's how it all started.
We ended up in Tarek and Whitney's workshop.
The Rex was attached to a stand, and she was able to put her arms into the Rex and for the first time be able to lift her hand up towards her mouth.
She just started, throwing her hands around and playing.
We were bringing candy up for her to eat. We were bringing toys up there, and it was so fun for us to go up there and to see her play.
The existing Rex is all metal parts, and it's kind of big, and Emma was too small for that. So we required something light and small that would attach to her body and go with her. So that's where we had this Stratasys 3D printing machine, and we thought, well, we could print it out for her.
And he did it, and the weight difference is significant. And for a child who only weighs 25 pounds, it makes a big difference. Whitney and Tarek put their minds together and came up with a jacket, and they would put the Rex on that. And we're on our second jacket. She outgrew the first one, and now we're on our second one. And it's still evolving. It's still growing into this incredible prosthetic that helps her to use her arms.
Without the 3D printer, we would not be in a position we're in with these younger kids, making them a Rex device that can go with them.
This is one of those industries that matches perfectly with 3D printing, additive manufacturing, because we need custom everything.
I think 3D scanning and printing technology is the future for this field.
The ABS plastic that they use is the same plastic used in Legos. It's human-friendly, if you will. It's really strong and durable to handle the abuse. We can answer a need in a heartbeat.
If the Rex breaks, all I have to do is take a picture and email it to Whitney. He knows exactly what the piece is. He prints it out. I go to the hospital, or he's even mailed them.
I don't have to worry about lead time to machine something, order supplies. I can just basically go back to my program and print out another one.
And it's back together and it's working. When she started to express herself, we would go upstairs and we would say, Emma, we're going to put the Rex on. And she called them her magic arms. And everyone in the room cried.
We took it off of her on this one occasion to make some adjustments to it. And as we took it off, she cried out, I want that. And we didn't think all that much of it. But when Mom started to cry, and we look over and ask Mom why she's crying, and she kind of takes a moment to recompose herself and tell us that that was her first complete
sentence to be a part of that, a little special moment for somebody else. Can't help but kind of tug at your heartstrings.
Wow. That's really something, Bruce. Thanks so much for sharing that with us today. We've got some time left here to ask questions of our panelists. I see here we have some terrific questions that have already been posed. Let me go to the first one here. And Bruce, I believe this one is for you. What developments are underway to provide thermoset fiber reinforced 3D printed products and materials? And I believe that would be an example there would be glass. Bruce?
Yeah. So, one of the challenges for all of us in the 3D printing industry, there's something like 4,000 engineering plastics, and knock on wood, Stratasys serves about 1,200 different materials. But I can tell you that, without letting too much out from behind the black curtain of what's in development, our largest investment in the R&D side is really in the material side of stuff. We see that we can build machines that produce great parts, that produce pretty parts, but when you actually start when the rubber meets the road is really on the material side. So I would love to be able to sit here and tell you that next week we're going to come out with a glass-filled nylon or something along those lines. I can tell you that development is progressing rapidly within Stratasys' four walls and our competitors' four walls. So I think if there's a common, I won't say an exotic material, but if there's a common material that you're used to using in your day-to-day products, I'm going to bet that Stratasys or one of our competitors or both are working on bringing those materials to market fast. It's a huge focus for all of the companies.
Great. Well, we have a question here now for Kevin at Four Moms. What additive materials are best for testing mechanically complex features like snap fits? Kevin?
Yeah, that's a great question. We have utilized ABS, PC ABS for exactly that. We've made them able to print in such a way to actually do fit-ups between two parts that are both independently printed or printed in the same pallet. So that's worked quite well. For very large parts, you might notice some, might not be a perfect fit, but for most of the applications we have, that fit between two adjacent pieces works quite well.
Great. Well, another question now for Bruce. What would you consider to be the future of 3D printing composite materials and how this might compare to traditional layup methods? An example is given are carbon fiber and Kevlar. Bruce?
Yeah, that's an interesting question as well. Again, it goes back to what I said before, that there's lots of material development. But what's interesting, we have lots of customers now that are we have something called a soluble core application where we actually print the core that's going to be soluble. So folks are using the 3D printed part for the carbon fiber layup, and then the core itself gets dissolved away. So they're actually utilizing 3D printing kind of in the process right now, even though the actual final carbon fiber or Kevlar is being printed. 3D printing is being used in the method of actual carbon fiber layups, and you're allowed. That allows you, because you can produce things with a 3D printed soluble core that you can't do in traditional manufacturing or traditional layup methods. And again, the comment I said before about the entire industry looking at new materials, Kevin referenced some folks actually starting to come up with carbon fiber materials already. That's going to happen, and it's going to happen relatively fast.
Bruce, a follow-up question here from another member of our audience. How do you see 3D printing influencing MRO supplies and the spare parts marketplaces in the industrial sector? And would you see end customers buying printers to make their own parts, or as a means to better position a manufacturer's service department when responding to a customer's post-sales repair support needs? Bruce?
Yeah, that's another great question. I think you're going to see multiple ways. It's interesting. I talked to some folks in the airline industry, and we all sit on planes and oftentimes get stuck in particular airports because of it. The question of actually putting 3D printers at LAX and at Logan and at JFK so that when planes land, those parts aren't in a depot. They're not sitting. They actually, as the plane leaves LA and it's going to land in New York 6 hours later, the part's actually being printed, and it's kind of on demand for spare parts. So I think it's going to affect a lot of companies. The question of I broke my radio knob off my radio at home. Can I download the file and print it at home? That one's maybe a little bit further out. Is it I download the file, upload it to Home Depot, and go to Home Depot to pick it up? That maybe is a little bit closer. But I do think having 3D printers help organizations from a spare parts perspective in the service department is very real and is happening. It is happening in some companies, and I think it's going to impact many more in the not too distant future.
Kevin, a question for you, and you touched on this in your presentation, so I think the listener just wants some elaboration. Without 3D printing, what would the product design process have been like, and what is the biggest benefit you get from the technology? Kevin?
Sure. The biggest benefit, of course, has been time. Our ability to get things right and get them out without 3D printing, which of course is the way many companies still work, and certainly companies in the past obviously worked, was a longer process of prototyping. Maybe it was milling machines, subtractive manufacturing in order to cut a part, test it out, and so forth. But many parts today are more complex. They have free-form surfaces, internal features that would be very difficult to machine in any material, and so as a result, your design freedom in order to do that in the prototype stage is somewhat constrained. The 3D printer just gives you that capability to make a part of any almost arbitrary shape. So prior to 3D printing, the traditional design and development process would have taken much longer, especially if you wanted to mold a part and test things out and get them in front of users. It was just a whole different world.
I do want to remind the audience we still have more than 10 minutes here to answer your questions. We do have a few in the queue, but continue to post them if you would. So one of the listeners currently has a $2,000 3D printer, and he or she wants to know how the high-end machines compare when doing product development and design. So I guess that could conceivably be a question for each of you. Bruce, you want to tackle that first? Again, how the high-end machines would compare to the listener's $2,000 3D printer.
Yeah, sure. Again, not a knock on the 2000 3D printers at all, because I think that they are serving a great purpose. They are opening up the world of 3D printing to many, many folks. But I think, Formobs is a prime example. I think their first investment was with a Stratasys 3D printer that was a bit more expensive than the $2,000 one, but they didn't jump feet first into the Fortis line. They started a bit smaller and understood the benefits. Again, you'll have to weigh that where you are in your organization, but as you start to move up the food chain in terms of cost, things like more material availability, size of the part that you can actually print, speed at which you can do it, workflow, things along those lines, impact quite a bit. And again, the $2,000 3D printer is a great napkin sketch tool. It gets you into the thing, but it's not. If you're doing what we refer to as industrial 3D printing, it's probably you could get a lot more value from moving into a higher end printer. But I'd love to hear Kevin's opinion on that. I don't even know if you guys own any of the maker stuff.
And I love that. I have my own personal printer at home that I've been building myself. It's a Delta configuration device. It's just for fun. Exactly as Bruce says, it really gets people used to it, how you handle the files, what the control looks like. But to have really what I would call a business or industrial printer I would say that the reliability and the throughput are vastly different than you would get in a small, the most famous small manufacturer, I think, is MakerBot. They have some very good small printers, but I couldn't use it for this sort of uptime that I need for prototyping and the design side. With that said, I think there's a great deal of use for that. I think it's a fantastic way for a company who doesn't want to even make a $20,000 investment to at least look at it and try it out. And I think you'll find, as we did, that the investment's very worthwhile and really helps accelerate. And even, there's an intangible aspect to this. 3D printing really motivates engineers. You see them have a lot of fun with it. We allow some personal projects here as well. So in the evenings between the other prints, if they need to print a replacement part for something, they'll do that, or they come up with a clever idea. It's really remarkable how people support it and drive it and use it, and I don't see that changing, whether or not you're using a very small, inexpensive printer or even the large ones.
This is a great question, actually, and I think both of you could respond, but definitely it's directed to you, Kevin. And the listener wants to know, did the staff at Four Moms need any special training to use the printers?
That is a great question. Initially, with the first U-print, we did not. There was some... we knew how to download the file, create the STO file from the CAD, send it over, the slicer, and then make it. There was someone who came here and did a little bit of training. Subsequent to that, of course, with the larger number of printers and the 3 different types of printers that we have had training. We've had technicians in-house who work with us, and it really was, for a full-time person, he had no experience in using 3D printers. He was quite familiar with subtractive manufacturing, really wanted to learn, and was motivated to do so. And he ramped up very quickly over a period of a month or so. Meanwhile, of course, the engineers who were already using it were able to sort of teach him some of those things. So it didn't require, it wasn't a huge ramp up. The basic principles are the same for most 3D printers. And I think the time and training, although it helps, isn't absolutely necessary. But perhaps as printers get more complex and require more, there may be a need for that.
Bruce, you had introduced us to some other Stratasys customers. Maybe you could provide some insight into this question as well. Again, the listener is asking about special training.
Yeah, absolutely. And as Kevin pointed out, the machines themselves, as you get more sophisticated and get more complex, they require more training. One of our machines we have, I referenced it, that Fender Guitars has, is our Connex machine. And so that machine has the ability to blend 2 materials together. So I can take 2 materials, a very rubber-like material and a rigid plastic-like material, and blend them together to get 14 different mechanical properties or different colors on the same part. So it's a little bit more sophisticated. It provides some more value. If I'm Trek bicycles, I want to print the bicycle that has a moving chain, the tires, the wheels, the seat, and the handlebar grips and the frame all at the same time. That takes a little bit more sophistication and a little bit more know-how, so different applications. If I want to print a mold, things like gates and how it's going to be, what its design is so it functions well in the actual injection molding machine. So application uses are where we're seeing lots of customers asking for training. It's not so much about how to turn the printer on and get it to print a part. It's how do I design for 3D printing. That's really where we're seeing lots of folks needing some
and that's actually a great segue into this next question. One of the listeners says, that I guess both of you have talked quite a bit about prototyping and product design with respect to 3D printing, and the listener wants to know, a bit more about where it stands with regard to manufacturing applications. And Bruce, you commented quite a bit on this. Would you mind elaborating?
Yeah, sure. And again, I divide that into 2 spaces. One is we refer to it as augmented manufacturing, so helping out the manufacturing floor. And then there's end-use parts. So let me talk about both. The augmented manufacturing, I would say that it's probably, we poll our customers and they're using it in 20% of their instances. The other 80 is still on the design side. But I will tell you that side of the business is growing rapidly. We see lots of uses and lots of customers actually buying printers dedicated for their manufacturing processes and development. It's actually a new phenomenon. I won't call it a new phenomenon, but it's something that folks are actually looking towards. The end use part side of stuff, again, it depends on who you are and what you're doing. Again, low volume manufacturing. I'm a aircraft manufacturer. I'm going to make 25 air ducts over the next 2 years for the aircraft I'm building. That makes sense. As Kevin pointed out, when you start to talk volume manufacturing, the technology is not there. It's going to change quite a bit, but that's kind of the two areas that I see. The end use part stuff, I think is we need some new technology, we need some new material, things along those lines before we're going to reach a tipping point for that. The jigs and fixtures, manufacturing applications, it's here today, and you can benefit from it. Kevin, I don't know if you want to shed any light on that at all.
Sure, we do exactly that. There are a variety of fixtures we use both in the development side for assembly. Sometimes those transition to the manufacturing floor as well. And then when we're doing testing after sub-assembly is integrated into the machine, we'll often have 3D pieces that we'll either supply as a part that we create in-house or use a service bureau, or in fact just send the file to our factory and they'll go ahead to print it. But for the manufacturing, we're looking at turning things off the line in 30 seconds or so. So it's pretty difficult to see 3D printing being there in the very near future, but I have no doubt that in the future these systems, especially running in parallel, right now most of the tools have a single endpoint, so it's sort of tracing out layer by layer the part, but in the future you can have parallel extrusions and parallel ways of assembling these things. So we certainly see that in the future.
Gentlemen, I have a question here as we wrap up this. It looks like we just got another question in from the audience, and I'll postpone my question then for a second here. So, and this the listener wants to know how big of an issue is warping when printing large. This would be 10 by 10 parts in ABS. So, I guess Bruce, you want to tackle that?
Actually, you know what? I can give him my viewpoint, but I think Kevin, you have real-world experience with this, so I'm gonna kick it over to you, and then I'll comment afterwards.
Sure. Yeah, there is certainly when you're trying to maximize the volume of a part, and let's say you have a 16 by 16 by 14 volume, which is roughly the size of the Fortis volume. Going to the very large parts will cause some, and it's mostly due to the heating and cooling during the process as it's made. But they're not bad, and they're often flexible, just enough flexibility to allow you to fit that into a larger assembly. In fact, very often, first shots off of injection molded tooling is much worse than what we see in the 3D printed part, and we end up spending time to tweak the tools themselves in order to get that part and properly cool it while it's being molded. But with the 3D part, it's unless you're going for very thin walls and very small features, it does a pretty good job even at the larger sizes within those volumes. There is some warpage, there's no doubt, but we've been able to prototype with that with usually very little problems. And sometimes it's a function of the material. Also, another thing that does affect the printers is how the material has been stored. If it's been opened out of the sealed bags, if it's been exposed to high humidity, that actually affects the performance of the machine. So management of the materials, the spools of the material itself is also very important. And we've learned that both the hard way and through time. The other thing you sometimes get is greater accuracies near the home position of the device. So instead of making it way out on the platen in the middle of it, that you try to be in one corner of it. Orientation of the part also affects resolution. So there are a variety of little tricks and tips that you learn over time to maximize the resolution and to get the best surface finish you can.
Bruce, I got about 1 minute left here if you can respond to this last question. Just came in. Are there any 3D printers on the market today that can integrate conductive and dielectric materials in the same layer? And if not, do you see that happening in future? Bruce?
Right. I actually I don't know of any specifically that do, but there are people that are utilizing 3D printers in different ways and kind of experimenting. And I would ask folks to look at Disney 3D printing. Do a Google search for that, and you'll see what Disney is doing with that. They have a great video on some stuff they've done with our printers before to integrate dielectric material and conductive materials into 3D printing. And although it's not it's not available today widestream, it is absolutely a focus for us manufacturers in the 3D printing world. So.
Well, as you said, progress continues in this field, and that concludes our webinar for today. I'm sure, audience, you found our expert commentary is fascinating and indeed as enlightening as I did. I want to thank you both, Bruce and Kevin, for your comments today, and surely we're indeed at the forefront of what will increasingly become the norm. I hope everyone enjoyed this, and I wish you all a very happy and productive rest of your day. Thank you.